I have selected a project which is in MS Word format and PowerPoint. The project is currently in students' hands, and the PowerPoint is one that I've used successfully with students in the past. I'm quite fond of the Word project. The PowerPoint contains some features that may not translate well into an online setting. I thought it might be interesting to use a screen reader for these resources. In attempting to do so, I discovered that there really is no good screen reader to correctly interpret math symbols. The most comprehensive project for making math readable is MathML, which is an extension of XML. The NVDA screen reader, available at nvaccess.org, frequently reads the math encrypted in MathML correctly. Narration in Windows 10 does not, nor does the Chrome web browser screen reader Chromevox. Formatting math for screen readers is time-consuming. Microsoft Word's inline equation editor does not produce output that is in MathML format. MathType is a program that can be added to Word and does produce the correct format, but Word files can be buggy when shared between users if not all of the users have MathType installed. Both the project and the PowerPoint provide interesting vehicles to compare using Universal Design for Learning and the Accessibility Handbook. First, the PowerPoint. The PowerPoint slideshow does not adequately address UDL guidelines. There is only one means of representation, the written word. Adding narration and some audio or video in the examples would help a great deal. These are exciting concepts of velocity and acceleration. Almost any video with motion could be used to illustrate the concepts. The biggest flaws of the PowerPoint with regard to UDL are the lack of multiple representations and the lack of student choice or engagement of interest. There are also accessibility concerns. Because of the theme of the slideshow, which has a dark background and light text, some students may have difficulty reading the material. Adding narration would help, but it would be a good idea to choose a different background entirely for ease of reading. I also perceive that some of the fonts themselves are difficult to read. The font we're looking at right now is a little difficult to read. The letters seem rammed together. The PowerPoint does contain highlights of the key elements. There are examples, but Stephanie Hoffman in the textbook suggests some non-examples might help. A non-example of velocity is speed, which is a similar concept. So some non-examples of speed would help. Some directions, perhaps allowing multiple means of representing solutions, would be an excellent enhancement to this in an online setting. It would be easy to create a graphic organizer to allow students to focus thinking on these concepts. The implied means of expressing understanding is the collaborative practice indicated on the last slide. Students are grouped to complete problems. This could be accomplished in the online setting with chat or shared whiteboards. Collaboration is a suggested practice according to the UDL guidelines. Addressing the accessibility guidelines, the slideshow does not use outline format. It does use a PowerPoint-provided slide layout. The reading order is correct. Although NVDA does an adequate job of interpreting the math symbols, alt text is an option for captioning some of the complicated math expressions. The link on the second to last slide could be improved by changing it to a descriptive link. In some cases, color is overused to convey meaning. The colors themselves may make accessibility an issue for some vision-impaired students. Math can be written accessibly in PowerPoint. It's just time-consuming. As I look at this slide, I see the red and the yellow and the black background. The font is somewhat small. I think some students might have difficulty reading that. Here's the link that could be descriptive instead of just the URL resource. And here's the indication that students are going to perform some collaborative work to answer these questions. I think that's an excellent address of UDL. Let's see if we can go back and get the NVDA screen reader to read part of this. Well, I tried to have the screen reader read that, but I think Screencast-O-Matic is interfering with the screen reader, and it kind of went on a wilding. So I edited that part out. We'll skip to the next part. All right, so let's look at the project in Word format. And that's Chromevox, which for some reason is putting in its 2 cents worth. Okay, Chromevox is now inactive. All right, so this is the Chapter 3 project. This is in Word format, and it's an excellent fit for UDL. There are some shortcomings that could easily be addressed, especially in the online setting. Assuming that these concepts have already been taught, this project provides opportunities to compose in text, speech, illustration, film, or music. It requires self-explanation, and students may choose to interact with the questions using different means. They can write, they can use the keyboard, possibly voice. There is some choice involved, especially in problem 7. As you read problem 7, I'm especially proud of that. In problem 7, students are grouped together, but they get to select their own problem. They've worked with these concepts, and now they can go out into the real world and pick an area of interest. Anything that moves in a circle is fair game for use in this project. I think of Ferris wheels or merry-go-rounds, railroad or automotive. Anything that moves remotely like a circle can be modeled with these concepts. And so students can certainly find something to interest them. The learning is personalized and contextualized to students' lives. They get to pick the problems. The outcomes are authentic. Active participation is a must, and students can experiment and explore. The entire point to the project is collaboration. There are opportunities for tutoring and support. Some prompts, reminders, and checkpoints will need to be provided. The project is composed in MS Word, so changing the font size or using a screen magnifier would be a Tier 3 assistive technology, and that could be implemented for this document. NVDA reads the document easily, except for the ratio involving pi on the second page. I'll show you that right now. Ooh, there's a pretty picture. The second page, this ratio involving pi, NVDA chokes on that a little bit. A simple fix would be to use the math type equation here instead of the native MS Word equation. That's suggested in the accessibility guidelines. Students with mobility impairments could use the Word document itself with Dragon speech-to-text software. That's a little buggy, at least my copy was. I happen to have a copy of that. Or since it would be an online assignment, they could easily use any number of speech-to-text utilities. I recently discovered Speech Notes, which works well for Chrome. Speech Notes looks like this. Well, apparently it's recording what I say. Might use this for my closed captioning. Speech Notes is available at the website you see there, speechnotes.co. Comparing to the accessibility guidelines, headings are not used, so this could be enhanced. Images do not have alt text. Adding the briefest of descriptions here might alleviate confusion. There are 2 images here, and these images are explained in the setup to the problem of number 1, but it may be helpful just to clarify to students that these images are in fact explained in question 1. Just a brief description in an alt text. NVDA does a nice job of reading the entire document, except for the ratio on the second page. And again, the math type equation would help there. There's no color, so I could add some color. Especially in an online setting, this wouldn't be difficult. And there are no lists or tables or form fields, which are indicated in the accessibility guidelines. But since they're not needed, I don't think I'd need to add them. Now, this is kind of in an outline format, and I allowed Microsoft Word to do the outline, and so that should be accessible according to the accessibility guidelines. And so there's my comparison of these 2 projects using the accessibility guidelines and the UDL format.